All right, recording again. If you see one radical in the equation, when we're talking about radical equations, we're obviously talking about equations that have this. Okay, this number can change. It sits out here. If there's no number listed there, what is the assumed number? 2. It's a square root. Yeah, that's a Roman numeral 1. All right, so when you see an equation that you have to solve that only has one radical, actually, before I show you that, tell me this. What?
Does that say I1 radical?
No, number 1, that's Roman numeral 1.
I was asking.
Okay. The first thing, yeah. First thing we want to do is isolate. Now tell me, what does isolate mean? Get it by itself. So we're going to isolate the radical. Then we should be able to get rid of the radical. And we're going to talk about how we get rid of the radical. Then get rid of radical. Some of y'all like steps. We're getting ready to do that. This would be step 1, step 2, step 3. I think that you will find it pretty easy to isolate the radical, but the question is, how do you get rid of that radical? So, if I have something like this, how do you get rid of that radical? And we've done a little bit of this before. It's already square rooted. I raise it to the second power. And I do it to both sides. And the reason I raise it to the second power is this root is a 2.
Okay.
Yeah, no, I can go back now. All right, so the question was asked, what if it wasn't a 2? What if it was a 3? If the third root of x is, let's say, 2, how would you get rid of the third root? You put it to the third exponent. So the key here is, whatever the root, whatever this number is here, if you raise it to that power, they cancel out. Those are opposite operations. Okay? Right.
Because it's like if the sun shot at you, 1, right?
Right. That's right. Because anything over itself is 1. N over n would be 1. So let's say I had, we'll start easy. The cubed root of x minus 9 equals -1.
Okay, well, you add 9.
What's your first step? Why do you add 9 first?
You gotta get this. You gotta have x. You gotta isolate x.
Okay, so yes, you're sad, Matt, but you gotta isolate. I'm not gonna say x. I'm gonna say isolate the radical first because I only see one radical there. So yes, I would add the 9 to both sides.
So it'll be 8.
That's not right.
He is right.
You gotta cube it.
-1 plus 9
So what
is
is
8.
216? Right.
So,
If you cube it.
so the difference here,
There's a 3.
yes, I'm raising it to the third power. That is a bit confusing because 8 does have a perfect cube. You might think it's 2. Is it 512?
But it's not. It's not 12.
But it's not. It's 512.
512, but it's not.
Yeah. Square root of x plus 25 equals 4.
Well, you got a minus 25.
I got to look at the radical as a whole, okay? Is the radical by itself?
No.
Yes, all of this is under this radical, okay? So now my next step, which is step 2, is to get rid of the radical. No, Tyler. No, Tyler. Your mama knows you're in class. Tyler!
Because of that, correct?
So the second step is to get rid of the radical, so I square it to get rid of it. This gets rid of the radical,
Can you
yes.
put, a 2 on the other side?
So, okay.
Yeah.
So there's no 2 on little dip.
It's automatically 2. If there's no number there, it's automatically 2. Okay.
So do we not do anything to the extra?
Now solve it.
So you know minus 25
It's negative 9.
So wait, why don't we do anything with the 2?
We did. 4 times 4.
What do I do?
Put a 3 on
Divide by 2. Don't miss that step. The radical is not isolated. Now what can I do? You put the 3. Plus 3. So those are fairly easy, yes? Pause this and let you. Let's say someone asked earlier, what happens if there's more than just a number on one side? What if it looks like this? Is the radical isolated?
Yes.
Yes, it's isolated.
Yeah.
It's by itself. There's just some other stuff there. So my step 2 is still, yes, Kevin?
Would you have to combine it?
There's no like terms to combine yet because these sit under a radical.
You have to get
Not at this point,
Get rid of the
no.
radical and
The
then-
steps are still the same. Get rid of the radical.
Yep.
Now, here's the thing.
You could have told the other side, get rid of it.
I'm still not going to be able to combine because the left side becomes 7x plus 15, but look at the right side.
X squared.
I can't distribute in there, remember, because I'm adding. If you're ever adding or subtracting inside the parentheses, you can't distribute the squared. It becomes a FOIL problem.
Yay. I hate the foil.
So looking at this now, let's FOIL. X times X is
X squared.
Oh.
X squared.
Ooh, I got it.
X times 1 is
Okay.
1 times X is
Plus 1.
plus 1.
X squared plus 2x plus 1.
That's correct. Now, this looks like a chapter 1 problem. I have a quadratic. It doesn't equal 0 right now, but it is a quadratic that I have to solve. So now I have to rewind back to chapter 1 and go, how do I solve a quadratic again? I know I got to find my A, B, and C, you're right. But first, I have to make it equal what? 0.
Dang, we going all of this stuff.
So what you would do was just minus 15.
Minus 15. Why are you moving those and not the other?
To get rid of it.
Because they're already like summed down.
That's right. And if you can ever, you really want to always try to keep that squared term positive. Okay?
We always FOIL.
If there's ever a plus or a minus over here on this side when you square it, absolutely yes, you have to FOIL. You have to multiply it out. If it's not, if this was just square root of 7x plus 15 equals x, well then you could square each side then. It's still a quadratic and you'd still have to do the same kind of thing, but you wouldn't have to FOIL. All right. Not 2x. 7x.
Wouldn't you divide it?
You have remember quadratics have to be equal to 0 before you start solving them. Now, Some of you keep hollering about the A, the B, and the C. And I guess because you're wanting to put in quadratic formula, which is fine, but I could factor it. Factoring makes my life a whole lot easier than the quadratic formula.
Is it 7 and 2, negative 7 and 2? No.
Mixed signs,
No, yeah, negative 7 positive.
yes. -7, +2. Remember when I told you factoring would never go away?
Why?
That's why we spent so long on factoring.
And we're going to spend even more time on factoring.
GCF here.
X.
X. How about here? 2. How about here?
X.
That's right, Trey, on the line down from that. -7. So this becomes,
X plus 2, 0.
y'all are just getting a step ahead, but you're right. Now I set each piece to 0, which is what y'all were doing.
Can I flip it? I don't like doing that.
Yeah, sure. He wants his equation on the left and a 0 on the right.
7 and then X equals -2.
It's like everything ever done all in one.
No, it's not.
That's a big problem.
That is a big problem.
Extra work.
And I can tell you there'll be at least one like that on your test.
Only one?
No.
Only one. Come on.
Yes, ma'am. Did you have a question, Lakiana? I'm sorry. Yeah.
Why do we not distribute again for the X plus 1 part?
If that was X times 1, you could distribute, but when you add or subtract, you have to actually FOIL it out. You're welcome.
Can you go back downstairs?
Yes, ma'am. Y'all still y'all copying, or you got any other questions on that one? Okay. And it takes your foundational knowledge from chapter 1 to be able to do this problem. Yeah. Try this one and then we'll do it together. Now y'all, I don't know the answer yet, so. I will tell you that for your test and quizzes and things, whenever it's a FOIL kind of problem, I won't go any higher than a square root. Like I won't give you a cubed root that you got to times it by, you got to do it 3 times. You're welcome. Or 64.
Look, I thought you said we ain't got big with the homework.
Remember, don't distribute that exponent. FOIL it.
Give me a second, if you want to do it.
Did y'all get 7?
I did. I gave you a lot of seconds.
Younger walked in.
Did you get it, Rebecca?
I got 7. So get what? 70.
You got 7?
70.
That's the answer. That's the answer.
No, that's the answer.
Oh.
Did y'all get, what's the little 2 boxes? I don't feel like doing all that work.
I'm still on the back part. That's on like 6.
I'm gonna combine these 2 steps, so don't let it confuse you.
Okay, this is where I got this.
All right, if this is where you, guys, I'm hearing conversation that's not about math. If this is where you got stuck, we're looking for the 2 factors that multiply to 70 but add to 15.
Yeah.
7 and 10 doesn't work. 5 goes into 70 how many times? 14. 14 plus 5. Nope. How about, yeah.
It's not back.
Yeah. How about, well, let's just start. This is good that we're having to do this to remind ourselves. 7 divided by 7 and 10 does not work.
Unfactorable.
I hope I wrote the problem wrong. Right. All right, so if it's not factorable, which this isn't because I wrote the problem a little bit wrong.
Yeah.
It's supposed to be x minus 8.
Really? Are you serious?
It's okay. It's a good.
It's a good example.
Because now I know that I can't factorable. I can't factor it. So, you wouldn't have any choice but to use the quadratic formula. Remember, that's opposite b plus or minus the square root of b squared minus 4ac all over 2a.
Will we
Okay?
have one like this on the test?
It's a possibility.
Please don't.
No.
Wait, so you have.
Wait, what? No way.
All right, everybody listen. If it cannot be factored, and even if it can be factored, you can still use this method. But if it cannot be factored, you don't have any choice. B squared minus 4 times A times C all over 2A.
Will we have one like that?
It's a possibility. Two radicals. If you see two radicals, you need to get one on either side of the equal sign. Get them separated, I'll say.
After B, it's what for AC? Is it like plus, minus?
Minus. It's opposite b plus my squared of b squared minus 4ac, and then everything's over 2a. All right, so we got to get the two radicals separated, and then we're going to raise both sides to whatever we need to get rid of the radicals. And for our sake, the radicals will be the same roots.
Thank God.
And then all we'll have left to do is solve. So let me show you an example as soon as you... Here we go. Cubed root. Remember, if the root is not indicated, what is the root?
It's a square.
A 2, a square root.
Or 3.
We need to simplify it.
You're not going to simplify anything before we start. If you see two radicals, what does it say to do?
You solve.
Separate them. One on either side. Absolutely things. I'm going to add, because it's always easier to add than subtract.
Add 5.
I'm going to add this whole radical. I'm going to move that whole radical.
You're just going to cancel both of them out.
Yes.
Oh, you added to both sides.
It
Okay.
doesn't change anything inside the radical.
No, it does not. I'm moving the whole radical, so no, it doesn't change anything inside. So the left side becomes 12x minus 5. And the right side is now cubed root of 8x plus 15. Cube, exactly, Adam. Cube both sides, because when I cube both sides, remember, I can do whatever I want as long as I do it to both sides. Look what happens when I cube both sides. Now I have no radicals, which is quite convenient for me,
Because you get to, you know, so now you like term.
because now I can simplify. So I've got variables on both sides. Tell me what I need to do.
Like terms.
You need to get it to 0.
Well, this isn't a quadratic. This is just a linear equation.
This is easier than the other one.
It is. I told you it was easy.
Subtract X.
Subtract AX. That's what I would do first also.
You don't have to do that.
No, you can do, the order you do it is your
Just to give you the desire.
yeah.
What would you do if they were not the same?
Well, I won't give you any that aren't the same.
Wait, so you
Well,
can subtract 5x first if you want to?
So it'll
I
be
mean 5, sorry.
you could add 5 if you wanted to
Yeah,
first.
that's what I meant.
X equals 5.
Yes. Yes, so x equals 5.
That is so easy. That was easy.
Yeah.
I remember that, get you some.